So for all these problems, the focal length for the mirrors is 10 centimeters. 3 of the mirrors are concave and 2 are convex. And the object location, as shown in the second column, varies compared to the focal length. So let's walk through these. What I'm going to do is I'm going to go through each case, I'm going to draw the sketch, and then work out the image, location, and the magnification. I'm going to use color coding for my special rays, so I'll draw ray 1 in red, ray 2 in black, and ray 3 in blue. Alright, so for situation 1, I've got DO is 5 centimeters, focal length is 10 centimeters, and it's a concave mirror. So let me draw this with a ruler. Draw my principal axis, draw a concave mirror, draw my focal point and my center of curvature. I didn't measure how far out these were, but I made sure that I put my center of curvature about twice as far away as the focal point. Alright, so now I need to put in my object. My object I draw as an arrow with its tail on the center line and its head above the line. And since it's at 5 centimeters, it's going to be halfway between the mirror and the focal point. So again, I'm not going to measure it, but I'm going to try and be relatively accurate. So there's my object. Alright, so now I've got to draw in my ray. So I said ray 1 I was going to draw in red. And the rule for ray 1 is that it comes in parallel to the axis and it reflects through F. So it's got to come in through the tip of the arrow and parallel to the axis. So let me draw this. It's going to stop when it hits the mirror. Remember, the mirror reflects it. And then the rule is afterwards it reflects back out through the focal point. So it's going to go from the point where it intersected the mirror through the focal point and back out. So that is ray 1. Okay, how about ray 2? Ray 2, I'm going to draw in black. It comes in through F and reflects parallel to the axis. So it comes in through F, and it also has to go through the tip of the arrow of the object. So I got to make a line that goes through both F and the arrowhead. And that's my incoming ray. So I'm going to draw that until it hits the mirror. And then after that, the rule is that it reflects parallel to the axis. So let me try and draw this. So there is my ray 2 coming out. Alright, ray 3 we're going to do in blue. Ray 3 comes in through the center of curvature and reflects on itself. So it's got to go through the center of curvature and the tip of the arrow before it hits the mirror. So go through center of curvature, tip of the arrow. So it comes in like that and reflects back along itself. So there is ray 3. Alright, so I've got my 3 rays. Now my eye is going to be over here on the left side. Looking at this, it's looking to see where do rays 1, 2, and 3 meet. Well, it's not going to be on the left side of the mirror, right? These guys are diverging from each other. So my eye is going to trace these rays back onto the far side and see where they meet. So let me, again, use my straight edge. I'm going to extend them as dotted lines behind. And remember, I've got to extend the reflected ray. So for ray 1, this is a reflected ray, so I'm going to extend that one back. And if I drew these properly, they should all meet at a single point. And let me see here. Do this one. Alright, so there's the extrapolated. You can see that they all meet roughly around here. So that's going to be the tip of my image. So there's the tip of my image arrow. So there's my image. So if I look at this, I say, okay, my image is upside right, so it's upright. It's behind the mirror. The light doesn't really go there, so it's virtual. And if I look at it, it's larger than the object. Okay, so this situation is the situation of a shaving mirror. Okay, so when you look in your shaving mirror or your cosmetics mirror, you see an image of yourself that's enlarged and upside right. So a shaving mirror is a concave mirror, and you're sitting with your face closer to the mirror than the focal point. Alright, let's find the image distance. So I know 1 over DO plus 1 over DI is equal to 1 over F. I know DO is 5 and F is 10, so I can find DI. So 1 over DI is 1 over F minus 1 over DO. So that's 1 over 10. Minus 1 over 5. Since these are in the same units as each other, I don't need to worry about converting it into meters. I just need to know that my answer in the end will be in centimeters if I leave these numbers in centimeters. All right, so 1 over 10 minus 1 over 5. If I bring that to least common denominators, I've got, let's see, bring it to 10 as the common denominator. So I've got 1 minus 2 over 10. So that's minus 1 over 10 is equal to 1 over di. So that means that di is equal to minus 10. The biggest mistake that people make when they do these problems is they forget that what they solved for was 1 over di, and they got to flip it upside down. And remember, my unit here is centimeters. So there's my image distance, so it's 10 centimeters, and the negative sign means it's behind the mirror. Magnification is minus di over do, and I know both di and do now, so I do minus. Di is negative 10. Do was 5. So I get two negatives make a positive. So I get plus 2. So the image should be twice as high as my object. So my magnification being positive means that it's upright. The fact that it's a number larger than 1 means it's bigger than the object, and it's behind the mirror. Okay, so let's do the next one. So the next situation, what I do is I stay with the concave mirror, and now I move my object so that it's between the focal point and the center of curvature. So my focal point is still 10 centimeters. I move my object to 15 centimeters. So I draw exactly the same situation that I had before. So first, sketching my principal axis, draw my mirror, a focal point, a center of curvature twice as far away, and now my object distance, focal point's 10 centimeters, center of curvature is twice that, so 20. So my object's going to be halfway in between these two. So there's my object. Now I draw my ray. So ray number 1 I'm going to draw in red, comes in through the tip of the arrow parallel to the axis. So there's it coming in, hits the mirror and reflects. The rule is it reflects out through F, so it's going to go from where it hit the mirror out through F. So there's ray number 1. Ray number 2 comes in through the tip of the arrow and through F. So it goes through the tip of the arrow and through F and hits the mirror. So there we go, like this. And then after that it reflects back parallel. So go back parallel to the axis like that, ray 2. So you can see already, I can see that ray 1 and ray 2 are intersecting here. Let's do ray 3. Ray 3 should pass through the center of curvature and the tip of the arrow, and then where it hits the mirror, it reflects back on itself. So it's going to go like this. Now you can see here, I didn't quite draw my mirror far enough around, so I could extend this around like that. Alright, so there's ray 3. And I drew this nicely so you can see all 3 of my points intersect at the same point. On this side of the mirror, that's where the tip of the arrow is, so that means that my image is upside down. So if I look at this now, I would say my image is upside down, so it's inverted. It's on the same side of the mirror that the light comes in. The light really goes through it, so it's a real image. And it looks to me like it's larger. So 1 over di is 1 over f minus 1 over do. F is still 10, do is 15. So now bring that to least common denominators. Looks like least common denominator for 10 and 15 will be 30. So I've got 3 over 30 minus 2 over 30. So it gives me 1 over 30 is 1 over di. So di is equal to plus 30 centimeters. So the plus means that it's real, and it's about 30 centimeters away, which is 3 focal lengths. If you look at the picture, it looks like that's about right. So we did a pretty good sketch there. Magnification is going to be minus di over do. So minus 30 centimeters. Do was 15 centimeters. So I get minus 2 centimeters. So my image has a negative magnification, which means it's upside down. Sorry, there should be no units on that. Magnification is just time, so no units on that. The centimeters cancel out. So my magnification is minus 2, which means it's upside down, and the image is twice as tall as the object. Alright, so we're getting the hang of it. Let's do the third one. Third one now, I've moved my object to be outside the center of curvature. So my focal point is still 10 centimeters away, DO is 30, and I'm still concave. So let's draw that out. There's my principal axis, my mirror, focal point, center of curvature, and my object now is 3 times the focal length away. So let's say we're right over here. So there's my object. All right, draw my 3 rays. So how do I draw the first one? Tip of the arrow and comes in parallel. So I go like this, hits the mirror, bounces back through the focal point. Alright, so there's ray 1. Ray 2 comes in through the tip of the arrow and the focal point, hits the mirror, and bounces back parallel. So there's ray 2. Okay, I drew that a little bit wonky there. Alright, ray 3, it's going to come in through the tip of the arrow and the center of curvature and bounce back on itself. Alright, so there's ray 3, like that. Now I'm looking for where all 3 of those meet, and it looks like they meet right here. So there is the tip of my image arrow. So there's my image. So I would say my image is real. It's on the same side of the mirror that the light comes from, so the light really goes through it. It's inverted, and it looks to me like it's smaller. You remember the equation for magnification is DI over DO. So if the image is closer to the mirror than the object is, it's going to be smaller than the object. All right, let's do our equations. 1 over DI is 1 over F minus 1 over DO. So 1 over F is still 10. DO is 30. So our least common denominator is going to be 30 again. So I've got 3 over 30 minus 1 over 30 divided by 30. So I get 2 over 30, or 1 over 15. So DI is going to be 15 centimeters. And if we look at the picture, it looks about right, because remember F was at 10 and C was at 20, and it came out about halfway in between. Okay, so it really helps to use a straight edge. You can get the location pretty accurately. All right, magnification. Magnification, I expect to get negative, right, because it's upside down. So I got minus DI over DO. So DI is 15, DO was 30, so I get minus 1/2. So that means that it's upside down, and the image is half the height of the object. Okay, so in all 3 of these cases we managed to get it so that our numerical answers agreed with our sketch. Okay, let's switch to the last 2, which are for convex mirrors. Now, if you remember in class, we said that for convex mirrors, you always get what you see in the passenger side mirror of your car, that the image is upright, it's virtual, and it's smaller than the object. So I expect to see my image over on this side. All right, so first case, we have DO is 5 centimeters, and F is 10 centimeters. Now, since this is a convex mirror, when I write down my F, I should really write that it's negative 10 centimeters because it's going to be behind the mirror. So here's my mirror. I'm going to draw my focal point here and my center of curvature here. So both F and C are negative. So negative 10 and negative 20. Where's my object? My object is about half the distance to the focal point. So here's my object over here on this side. All right, let's draw our 3 rays. So ray number 1 comes in parallel to the axis through the center, through the tip of the arrow. So there's ray 1 coming in. Now the rule is it's got to go out through the focal point. So that would mean it would have to go out back here on the back side. Now we know that doesn't happen. We know what really happens is that light reflects back. So what you have to do is draw your reflected ray as though it would extrapolate, if it could continue through the mirror. Ray number 2 now has to pass through the object and the focal point. So I got to take my ruler, put it between the tip of the arrow and the focal point, draw it until it hits the mirror. So there's my ray 2 coming in, and then once it hits the mirror, it's going to turn around and it's going to reflect back parallel to the axis. So it's going to go back like that. So there's my ray 2 coming back. So you see, if I extrapolate, let me draw in a little dashed line, ray 2 would come in through the focal point. All right, ray 3 comes in through the tip of the arrow and the center of curvature. So I got to do the same thing that I did before. Draw a line that hits the mirror such that if I were to extend that line, it would pass through the center of curvature on the far side. So I can draw my arrow in like that. So and the ray 3 will bounce back on itself. So now if I look, I've got the same situation that I had in situation 1. If I put my eye over here, it sees 3 diverging rays that are getting further apart, and the eye extrapolates those back, and it assumes that they all originate from the same point. So if I take those 3 rays and extrapolate them back, so here's ray 2 going back, and remember, just like we did for the first one, it's got to go back along the line that it came out on. So there's ray 1 going back, and let's go to blue. There's ray 3 going back. And so if you look, all 3 of those meet at this point over here. So that's the tip of my image. All right, so there's my image, and we get what we'd expect. We get that the image is upright. It's on the far side of the mirror, so it's virtual, and it's smaller, exactly what we'd expect for any situation for a convex mirror. Okay, let's do the math. So 1 over di equals 1 over f minus 1 over do. Now remember, it's important at this stage, you got to remember to put in the f as negative 10. If you don't do it, you'll get the same answer that we did for case 1, where we had do was 5 centimeters and f was plus 10. And we know that our position should be different here. Right, so I've got 1 over minus 10 minus 1 over 5. So my common denominator is going to be 10 again. So I get minus 1 minus 2 over 10. So I get minus 3 over 10 is equal to 1 over di. So di is equal to minus 10 over 3, or minus 3.33 centimeters. Okay, so remember, this distance here was 5 centimeters. This should be about 3. So it looks like it didn't come out exactly right because we didn't measure things exactly as we did it. But it's enough to tell us that it should be upright, virtual, and smaller. Let's do the calculation of magnification. Magnification is minus di over do, and since this is upside right, we expect to get a positive number for the magnification. So if I put in my di as negative 3.33, my do as 5, I get that my magnification is plus 0.67. So it's 2/3 as tall as the object, and it's upside right. Okay, let's do the last case. So it's a convex mirror again, but now we move the object further away from the mirror. So draw the situation, same thing. I got my focal point and my center of curvature over here. So focal point now, again, since it's convex, is negative 10 centimeters. My do is 15 centimeters. So my object should be about 1.5 times the focal length away. So I'm going to draw my object over here. All right, my 3 rays. Ray number 1 comes in parallel to the axis through the tip of the arrow. Then it bounces back off the mirror so that it would go through the focal point. So again, I turn my ruler like this, so it's going through F. And there is my ray 1 bouncing out. Ray number 2 comes in from the tip of the arrow through F. So I take my ruler like this. There's ray 2 coming in. So if I extrapolated it, it would pass through F, and it bounces back parallel to the axis. So I go from wherever it hit the mirror, and I go back as best I can, parallel to the axis. So there's ray 2, and you can see again that these guys are diverging, ray 1 and ray 2. And ray 3 comes in through the tip of the arrow and the center of curvature. So again, I got to take my ruler and extend it like this. So ray 3 comes in like that, and the rule is it bounces back along itself. So there's ray 3. All right, so I put my eye over here. It sees ray 1, 2, and 3 coming back out, extrapolates them back to where they would meet. So let's see, I've got ray 1 already extrapolated back. I need to extrapolate ray 2 back, and I've got ray 3 extrapolated back. So they all meet over here. So now, if I look at this, I can see that I've got upright image. It's virtual because it's behind the mirror. And it's definitely smaller, right? It looks quite a bit smaller than the object. Let's do the math. So 1 over di is equal to 1 over f minus 1 over do. Again, put in that f is equal to minus 10. do is minus 15. Okay, so again, common denominator is going to be, sorry, do is plus 15. The common denominator is going to be 30 there. So I've got minus 3 over 30 minus 2 over 30. So that's minus 5 over 30 or minus 1 over 6. So di is going to be 6 centimeters. Now you can see that that's closer to the focal point than it was for the last picture. And that's what we'd expect. And I got to put a minus sign in front, which means that it's virtual. Magnification, again, we expect to get a positive number because it's upside right. So I got minus 6 over 15 for di over do. So minus minus gives me a plus. So I get plus 6 over 15, which is 2 over 5 or 0.4. So the magnification is smaller than it was before, only 0.4 times as high as the object. So that's a walkthrough of all the different possible situations that you could have to draw for the test. Make sure you can draw at least 2 of the rays for any situation and do a rough location of the image and be able to do the calculations for the image distance and the magnification.